All right, good morning everyone, and thank you for coming. We've got a really good turnout today, I think. There was at least one person coming today, so that's good. Today my talk is going to be on a lot of the geospatial online systems that we've developed here at Geoscience Australia, and I'm also going to talk about some of the things that we are developing, and I'm also going to talk about some of the systems that we're developing in now and into the future that will bring into alignment what looks a little bit disparate, but will actually start bringing these things together. And I'm even going to start talking about some futuristic and technological ideas that's actually probably most likely going to happen fairly soon. Anyway, let's cruise on. Okay, so what is digital transformation? As you can see here, I put a Wikipedia link to a definition. Some people cringe at those sorts of things, but in this particular case it's probably quite appropriate, because digital transformation is a fairly conjured and marketing term, but it really does mean a lot of different things. To executives and so forth, it is a strategic drive. You've got to drive these sort of things forward, and I'll talk about each of these things in a bit. But in terms of strategic direction, digital technology is critical to the modern public service. We have reducing resources all over the place, and we have higher and higher expectations from our government and our public people. But in that, we can't just go, each of us developing portals that don't talk to each other and doing different things, you know, people groan, oh, it's just another portal that does this and so forth. But some of the technologies that I'm talking about today will talk about how we can interlink some of these ideas together so they're not looking so disparate. And also, of course, with a strategic drive, you need to think about where you want to place yourself and where you need to be in the future to answer some of the demands for Australia. And we've been taking on a lot of those sort of challenges. It's also business-driven, of course. It enables us to demonstrate as an agency what we do and our outputs. We have a lot of scientific outputs which are really interesting to scientists, but that's not our only audience for communication. We need to make ministers understand, we need to make people understand some of the things that we do in this agency, and I'll show you today some of the really interesting things that we do in this agency. And we need to communicate that online, you know, less paper. People expect to see these sorts of things on their mobile devices and tablets and all these sorts of things, and they expect fairly closely that all these things are interlinked in some way. But it's also market driven. It needs to be useful, it needs to be usable. You can't just build something that's for one particular audience and then tell everyone that'll be fine for everyone, because it doesn't quite work that way. I'm going to talk a little bit about scientific audiences that have very specific type questions, and a couple of generic sort of applications which are just for the people who want to browse some of our catalogues and may not know of some of the things that we do and some of the things that we have. But it's all about enabling process as well. We've got a lot of these things. It's quite manual and labour intensive. We're working on techniques to automate some of these results and put them out, so we have less public queries coming through the sales desk and various different things, because people can find what they're looking for fairly quickly online. And, you know, treat the customer as a consumer, so we need to consider the things that they are looking for, what our Australian government is looking for, what the public is looking for, what the industry is looking for. And it's always about transforming business, you know, focusing on goals that will enable us to, you know, get a better understanding of science. You can put stuff up there, but in that, when you put things up and you study things, we need to also understand the absence of areas that we haven't done yet, or questions that we haven't asked yet. And some of the systems that we're talking about today will allow us to leverage those situations. It's very important in transforming business that we start reusing components that we build. We can't just build a new application every single time. But I can demonstrate today that some of the components that we're doing are completely reusable. You'll start to see some commonality and functionality through the presentation. All right. In that, we actually have an Australian Digital Transformation Office. And this is a machination of the current government, and it allows us to coordinate public services, because there is a high demand for people to do things online. They don't want to have to go into Centrelink. They don't want to have to go into the talk to the tax people. They want to be able to, they don't want to fill out massive forms in writing in pen and ink. People expect to be able to sit on their iPads at home and browse and interrogate and use public services. So this is for all different kinds of Australian public services, and these guys are coordinating. Basically, as it says there, the administration layer between our stakeholders, which is the Australian government and the people, and some of the systems, the things that we do as Australian government. They don't need to know how things function. They just need to see an end goal that will enable them to do the things that they need to do. It was established in July 2015 as part of, like I said, the Prime Minister's portfolio. It covers all the kinds of things as human services, Centrelink, tax office, health services, industry, innovation and science, which is of course our parent. And you'll see a couple of the topics that we touch on today. Our sciences actually touch a lot of those different factors as well. And we'll also spend time discussing today how these can become interlinked into the future. But it's got to be delivered simple, faster, cleaner, user first. They use lovely terms like big thinking, but there's nothing wrong with big thinking. I'll be talking a little bit about the data cube today. There's some big thinking right there. And it also needs to be flexible, because one day it'll be one thing, we'll have a new government, and the next day it needs to be utilised for a different purpose. All right, so if you didn't know, our key stakeholder is the Australian government, and of course their key stakeholder is the Australian public. We do things to enable our government to enact the policies that it's trying to put to the Australian public and the things that they were voted in for. But the system that they need to be easy, as we've discussed, maintained. We need to demonstrate as an agency our reason for being, and we have to demonstrate the scientific principles that we have and do, and you'll see some of the applications that we've got here today will do that. Because, like I said, you've got the scientists and various different things, and they really do appreciate the outputs that we have, but we need to also communicate these things to a more generic audience. But in that, we have to also, and we are, improving our metadata. Provenance, can I rely on this data? Yes, you can. We can just tell them that, or we can show them why they can rely on that data. And it's all scientific data, so it's actually very specific. So we have to also cater for a generic audience. And we have some really cool stuff. We want to be able to demonstrate how cool our stuff is in easy terms. So some of the stuff in the first section I'm going to be covering today are some of the applications that we have out there online functioning today, some as recently as last week. Also, I'm going to be explaining some acronyms, and we love acronyms in this place. So I'm going to actually say, hopefully I'm always going to say what the full term is and then tell you the acronym. So it's a little bit of a translation scenario. But I'll first start talking a little bit about service-oriented architecture and what's the commonality between these platforms that we're building, and why one day we could sweep them all away and evolve into whatever the next thing is. So service-oriented architecture is basically, it's an application pattern. And what we're talking about is building applications which are loosely coupled from the back-end system. So today I can be using my desktop or a server operating system, a cloud high processing environment, or an application using all the same services. And we're doing that much more than we did 5 years or 10 years ago. But like an email client, I expect to have my email at my desktop. I expect to have my email on my thing. I expect to be able to search, and types of functions that you would expect to do with email, they're quite common. You don't care about the server in the background, you just care about the utility of using it. And a lot of the applications that we're building today, I'll demonstrate, have some of these capabilities. So one interesting application that we have online is the CO2 pipeline storage planning application. Now, we usually do this in consultation, and there's a login situation here. I would hope one day that some of these tools become public, but you'll start to see after this a pattern of reuse and application. This is about clean energy initiatives for the federal government in terms of pumping carbon storage or, burning fossil fuels and pumping it into, hopefully, geologically stable environments underground. But of course, in that, you've got to design these pipelines from the processing plant through to whatever locations are viable for CO2 storage. But what this application does is allow people to use a bunch of sliders and things and a lot of multi-parameters to determine, is this a good place for a pipeline? And it's also done in near real time. It's also known as multi-criteria selection, and there'll be a few applications we're going to talk about today which have this. But what it allows people to do, and I use the word decision support, so it's not to make a decision, but it's enable people to make better decisions. So what you can do is you can put in a little line and you can set your parameters and you can set your sliders about which types of parameters, like lakes and reservoirs and easements, not the back might not be able to read that, urban centres and localities that are important to the construction of that infrastructure. And then it will tell you, using some heuristics and known mechanisms in the background, there's also, as you can see, there's also a path elevation type thing, because of course you can't go over the top of a mountain with a pipeline. You can try, but it's difficult. But in that, you'll put your pipeline in and it'll draw a heat map and maybe suggest to you different areas where you might be able to put that pipeline. So it comes up with real-time workable solutions for pipeline management. But in that, let's have a look at another example of using this. Now, this is a very interesting type of project. When people in this place, senior executives, saw the CO2 pipeline planning management, they thought, wouldn't it be interesting if we could apply the same multi-criteria stuff to economic potential or mineral potential areas? Because building a viable economic location is it's a huge investment. What we need to be able to do is, using some decision support first pass things, to determine an area of mineral potential, and is it even viable? Is there a railroad? Is there a track that can take trucks? Can you do it all year round? We have areas of flooding where some places are going to be inaccessible to traffic. But these sorts of things, and also things like, we have a mineral potential, like copper here, and based on the current grade and the top soil, the top cover it is, with the factors of building that road and building that pipeline or whatever it is it going to be economically viable? Again, it's just a serving suggestion. But what it allows you to do in near real time, to be able to put in these parameters and things and demonstrate to you if it's economically viable, or even possibly suggest with the graphs when it could be economically viable. So that's some really interesting capability. And again, just like the CO2 pipeline planning management, you've got some scenarios there that are reusable. But again, like the CO2 stuff, in the back end, the functionality is on the server. So these questions, you ask a specific question to the server and it gives you a specific answer. So you see the application, you may use the application, but we can actually one day wipe that away and put something else on top. And hopefully we have it in a metadata catalogue so intelligent systems can start to harvest it themselves later, but we'll talk more about that in a bit. Another one which we've helped the Australian government is radioactive waste storage. Now, I don't know if you know, but we produce a lot of radioactive waste storage via medical, agricultural types of activities. And we have over 100 locations across Australia, some of them temporary storage and stuff. So we are doing this, and it is happening. We need to find places that we can permanently store these sorts of things. Where are we? So, again, I mentioned agricultural, medical. We actually have a reactor which we do a lot of scientific research in. We process the rods and so forth after they've been used in France and the UK, and then we're expected to store them somewhere at the end of the day. This is happening, and so we need to find some places. So using the same principles and patterns before, we've got multi-criteria things about, is it geologically stable? What's the rainfall like? And so forth. And there's a whole process online where people submit their land as a potential site. And using this decision support stuff, we can fairly quickly start eliminating some of the silly ones, like it's in a national reserve or it's sitting right on top of a potentially unstable fault, which would not be great. There's also a website, interestingly enough, called www.radioactivewaste.gov.au, and they have a feedback section there, which I strongly suspect will be very interesting. But in that, this is happening, and in 2012 we actually created a National Radioactive Waste Management Act because we are doing this. We're generating these, most of the time, low-level radioactive waste, and we have temporary storage for them. It's not a healthy environment. But in that, the team can go away and assess these sites and quickly eliminate and give evidence as to why it can be eliminated as well. And there's, of course, a whole bunch of factors there in terms of community safety and all sorts of things as well that has to be taken into account. And naturally, of course, the public will provide feedback. All the sites that are being proposed are up and online, and you can say, hey, not in my backyard. All right, so another really interesting project, I think, and this project has a lot of information online about its origins and why it exists, is the National Risk or Flood Risk Information Portal. Now in this, it has a bunch of consistent delivery mechanisms of reporting of floods, and this pretty much all came out of what happened in 2011 and previously as well in flooding areas where insurance companies had a lot of trouble saying, look, we don't know what is a flood and what is not a floodplain and so forth. It's difficult to say who's insured and not insured. This helps enable some standards and guidelines about flood reporting. Now, like I said, there's a lot of information online, and there's also a singular point where you can come and check all the different types of flood reports across Australia. And as you can see here, there's a whole model about how we're going to start aggregating, or have been aggregating, state and territory databases all together in this one point where people can come and, using different standards and guidelines, investigate and start going through some of the flood reports. So there's consistency. And consistency is one of the most important things for insurance people and for the general public. So, if you were going to build a house in some place, it might actually be useful to go on here and have a little look. But this also goes into a couple of other things that we're going to talk about later, which is water observations from space, some science that we've been doing in the data cube. Let me go for time, not too bad. So this is another really interesting little website that we've got here called the Recent Earthquakes. And allows people to search for earthquake activity. Like I said, you can search it, you can do public reporting, there's notification, there's seismic graphs of activity and historical stuff. So you can look, you can go through and you can see some of the activity that we've got going on there. And also this sort of stuff enables us to create earthquake maps, which give historical reference to the earthquake activity across Australia. This is part of the community safety program, and it is our commitment to Australia to be able to say, look, we know we have a lot of science, we have a lot of capability in this agency. Do you want to contribute? There's Twitter, there's RSS feeds. I find it really interesting that we've got these Twitter feeds and RSS feeds. They're generated by robots, and other robots are reading it, so we're sort of like socialising robots to read. Eventually we're going to get to a stage where I can't be reporting I can't be bothered tweeting what I'm having for breakfast, so I'm just going to get a robot to do it and some other robot will read it. Yeah. Eventually they'll become intelligent and they'll have problems. But again, there's about crowdsourcing, and you can actually have people saying, look, I felt that movement, I felt that shake. And it gives the community a little bit more input into things, and if you get enough reports, just like a crowdsourcing situation, it's probably an event that's happened. All right, so this is a brand spanking new system called ELVIS. There were worse acronyms. It's the Elevation Information System, and what it allows us to do is put in one place and let people take, whenever they want, some of the best available elevation data across Australia, because we used to have a system where we have it on disk and we'd send it to people, or go fetch it from this FTP site. What is the best elevation data in this area? You'd have questions all the time about that. This sort of system allows people to go online and interrogate and download for themselves without any logins or anything like that. It replaces an application called Netif, which died a little bit last week, so it's good timing. but you can process in near real time. Within 5 to 10 minutes, you can do what's called a zip, clip and ship. You can request something, the server will go away, and interestingly enough, it's in the cloud. This is one of the first applications to be put out there in the cloud and online for GA, which is another interesting topic. But in that, within 5 to 10 minutes, you can have an extract of exactly the type of elevation that you want from that area, and it's available to everyone. So actually, this is a really interesting little project. Again though, just like the previous systems, all the applications and functions are back-end services. So the application is pretty cool. But tomorrow or next year or 10 years, it could be something else. Or it could even be an intelligent system going around querying for us, and we'll talk about that a little bit more later. A little bit of crystal ball gazing. Okay. Another one that's up there and out there today is called Sentinel. So this gives you hotspot locations all the way across Australia from satellite-borne imagery. We basically have a full scene every two to three times a day, so we're always updating this, and it takes basically essentially the infrared spectrum. It processes this stuff in Alice Springs and then just sends us through a small text file. And we've been doing this for a good, I think, 20 years now or something like that. So we actually have a large amount of historical hotspot data. In fact, when the Canberra fires happened, you should see some really cool stuff as it moves up along the line. And I've actually been requested before for people to actually download that to do reports. But the fireys and emergency services do like these sorts of things. Of course, you get things like, when it's industry and there's a coal-fired plant, it's going to create heat. But there's a lot of stuff going on. As you can see, there's a lot of stuff going on in Tasmania at the moment as well. And it's using satellites 2 to 3 times a day. But interestingly enough, one of the things that's moving to is a Himawari satellite constellation, which is in geosynchronous orbit, which is above the equator, and so it moves exactly along with the Earth. So it's continuously taking snapshots of the South Pacific area, or the whole Pacific region actually, sorry. And it's a weather satellite, but in that it's got these multi-sensors and so forth. But what it means when it's geostationary, we could potentially process real-time, but we're going to go for near real-time processing of these Sentinel hotspots. So we can tell you at any given time, and this is coming fairly soon. Himawari is a Japanese satellite constellation, and through BOM we have a collaboration there. But in that, we're going to have also scenes coming down, so giving you the latest satellite imagery as quickly as we can push it through the pipeline, basically. But in that, and this is going to link into some other concepts later, we have 1.2 petabytes of Landsat, MODIS, NOAA sort of data right now. And I'll talk a little bit about the data cube in a minute. But by 2025, we're going to have 20 times that storage and capability. Historical imagery, constant real-time imagery. Now, that's a lot of data. And that's just one example. Satellites is just one example of data growth and data migration. In that, we're going to start creating problems for ourselves if we don't invent new ways and smarter ways to search and look through that data, because brute force methods are just not going to work anymore. So, something near and dear to my heart is a little application called Interactive Maps, which I've recently created. And one of the goals of this application was to replace a famous little application called Map Connect, which allowed you to browse and look through different types of data sets from the agency and download and use, interrogate and look, just have a little look. Because we're creating lots of web services. We've got over 130, 140 web services in GA. You need to be a little bit of an expert to look at them. But these sorts of platforms, which are meant to be simple, they're meant to be basic, allow people to browse through our catalogue and find data and find related data. So, the common portal, you've got the map there and you've got the empty text box and you're expected to type something to find things. Now, you'll go looking for exactly what you want and you'll find exactly what you want, but this sort of application allows you to, in scientific categories, to put things side by side, a little bit like IKEA catalogue, where you're looking for a couch, you find your couch, but you didn't know that they had those pillows or vases, and you're also interested in that, but you didn't realise you were. But in this, we don't charge, which is quite useful. And that's one of the popular things about Map Connect. It allowed people to look and see the data before they took it. Because back then, even now, it takes a little while to download things. But if you can investigate, interrogate this stuff before you get it, people really do like that. Now, this is all open source. So it's all done in open source, and it reads from multiple different services, not just in Geoscience Australia. It reads NCI, Threads, it reads One Geology and various different things. And it's fast deployment, it's relatively fast. It's a toolbox. So when we build a tool, we rarely ever build one solution for one problem anymore. When someone comes to us with a problem, we build it in such a way that we can configure it to solve other problems that we know are going to be asked in GA. But in that, we have now covered pretty much, possibly 70 to 80% of what people require when they produce a spatial product. And let's face it, at least 90% of our projects in GA have a spatial component to it. And people do expect now to see these things. In that, you can reuse these things, and you can very quickly develop these applications. And let's go through this. So again, it's completely open source. You can read multiple different sources. It works in a modern mapping browser. It also works quite nicely on the tablet and phone. It needs a little work, but it's not too bad. For instance, we can create QR codes on posters and cards. You can click on it, and that poster that you're looking at, you'll be able to play with it and zoom in and out on the map and have a little look. It's simple geospatial discovery. Like I said, it's meant to be like an IKEA catalogue. You put things side by side that are relevant to people, and you can explore. And we've had people before, they look at things and they said, I didn't know you had that, and I didn't know you had that. Now in a catalogue environment, our current catalogues do have related items, but we need to work on it a little bit. But this sort of environment gives you that. But also one of the significant strategic points of this application are people have an appetite to use it. The developers like to develop in it, which means when we start bringing a bunch of stuff under this banner, whatever the next thing is, we all move together. And that's actually a really useful tech debt situation, or solving some of the tech debt in the agency. So it's write once, use many. It's all open source. It's up on GitHub. Who do we have interested in it at the moment? We have the Canadian Hydrographic Service is interested in it, Indonesian University, Griffith University, AMSA are really interested in using it, and Department of All these guys have expressed an interest in this kind of application because it's simple and it's meant to be simple. So again, it's all about your audience that you're going for. And some applications in this place that are already looking at using it, the next acreage release should be up on here, so you'll be able to go in there and interrogate the acreage release results. And in that, against the acreage release stuff, there'll be a whole bunch of geology, geomorphology will probably be there, and some petroleum things in that system that you can look in online. Anyone can look in online. All right, I was going to give a demonstration, but you can go play with it. It's on the website. ANSYS is another really interesting application here. What we're talking about here is a legislative representation in a geospatial format. And that's very important. When you've got legislation and you've got these things like EEZs and so forth, it's a very large, I've seen the printout, they're very large, and it's a bunch of coordinates. And what we're doing here is providing through service endpoints these geospatial coordinates, which is representation of Australian legislation. It's designed to be, and here's a quote from Mark, it's designed to be a spatial extension of the Federal Register of Legislative Instruments and coordinating to a point of accessing information for marine spatial planning. Ooh, what a quote. But it also links into the kinds of things that other international agencies like the US and France and various other people are doing. And even the South Pacific are putting their EEZs and they're registering them with the UN for boating and fishing and so forth. And wouldn't it be nice if we could start building up a system where we can understand where everyone's federal zones are. And of course, Border Protection Force are very interested in these sorts of things because we are the authoritative contact and point for these sorts of kinds of things. So, what observations from space? I don't think we've had enough presentations about the data cube, but no. But in that, this is one of the results, and I think it's a really cool result that's come out of the function that is the data cube. What observations for space is is about 28 years of historical observation of presence of water on the planet across the whole of Australia. And interestingly, with the enhancements with the data cube, originally it took about a day to process the whole of Australia. Now that's pretty significant. Again, the algorithm detects the presence or absence of water, and we found some really interesting things there. The kinds of things that we're working with the scientific data is wetlands, changes to coastline, mangroves is another really interesting thing, intertidal zones, high and low tide, and one other interesting aspect of this is we're going to be applying perenniality, or whether it's all year round or not all year round presence of water in our surface water, and of course that will also link later on down the ways to groundwater. Another interesting project that we're going to be working on in NLI is the presence of water on infrastructure such as roads and rail, and the impacts, the historical impacts of that on that infrastructure. Well, that would be really good because we could find out what roads are underwater, what percentage of the time, and there's costs and maintenance things to all the different states on that. So we can apply this information to many different areas, but when you think about it, this is just water. What else could we do? We could also do forest monitoring. We could monitor urban expansion. Again, fairly quick processing time. We can also get historical, because we've got heaps of historical landscape stuff. We could build up full pictures of our urban expansion across Australia, or some of the forest and vegetation impacts and changes. That links into things like climate change and various different things. Okay, there are limitations, of course, to these sorts of systems. You don't always see the presence of the ground. You've got cloud cover and so forth, so you don't always get the same scene every single day. But in this, they're inventing systems where you can find out on a particular day from a particular scene the absence or presence of water. So that's a really interesting little function. So now I'm going to go into a couple of little applications that we're currently developing today and into the near future, and should be released as some sort of system soon. Okay. The FSDF, or Foundation Spatial Data Framework. I could spend a long time on this, but I won't. What this is about is an NLI project. What we're going to do is we are going to all the states and territories, and we're saying, what's your best available topographic related type data in your area? And what we're going to do is we're going to create a singular registry where we're going to put all these things in here. We're going to talk about who made it, who's it for, what is it the best available, or is there something better? We're going to start putting these things together in a registry, but not only that, we're going to actually give context to the data and some of the relationships that the data has. Now, all the states that we've gone to are very excited by this proposal because people buy lots of data and they get it, and think about all the money that gets spent twice, 3 times. What we can do with this registry is we can start seeing some of the gaps or commonalities of the data sets that people have, and start looking at maybe some whole of government arrangements around some of that data, so that we can become more efficient with our spending. But again, it's about giving context. I mean, you can put stuff up there, but if you don't give it context in relationship to the things around it, it's a little difficult to interpret. And we'll talk a little bit more about that also later. But as you can see, in this registry, the custodians will be the master of their own domain and be able to register their things. A lot of these guys have got catalogue systems that we can read today. But they're really interested in this because then from this singular website you'll be able to go through and get stuff from across the pond or across the border, which they haven't necessarily been able to as easily as in the past. And in that, of course, there'll be provenance in terms of can I rely on this data? Is it any good? Sometimes it's not very good, but there's the only thing we got. So you put it up there and you say, it's okay. But it's the best we got. Another one near and dear to my heart, of course, from NLI is the National Exposure Information System. And we are collecting a lot of national data sets which span across the whole of Australia, reflecting or that have influence in natural and man-made types of disasters. What we're really talking about are critical infrastructure, points of logistics, built environment areas that are affected by cyclones and fires and things like that that really affect the Australian public. Now, we're going to be creating a bunch of tools. We've already created a bunch of services which allow people to interrogate at statistical areas and LGAs. But we're going to be looking at building tools where you can put in, say, a burn scar or flood extent. And the result returned will be the impacts, the number of buildings. It will disseminate the information to say, look, the possible number of families and you know, children that may be affected in that area. Commercial, industrial, residential. These sorts of things, in being able to plan for an impact or be able to respond to an impact, is really quite critical. And there's a lot of innovation going on in this section. Hopefully you got some brownie points right there. We are also creating a new datum for Australia because the old one is over 20 years old. Now, if you didn't know, we're on a plate which moves. And it's moving slowly, but as you can see here by this diagram, the original stuff was this sort of error, but the new datum is going to start taking into account this sort of error. Now, some of you may just say, well, what's the point? There's only 1 to 2 metres shift there, who cares? But think about some of the things that are being talked about today, like driverless cars and drones, airplanes that use GPS systems. All of these sort of systems are here today and being promised into the future. It's really important for us to have an accurate location on the Earth. It's very important. Again, 20 years ago, we've moved, and moved quite a way. And it can mean the difference between, you know, being in the centre of the road or being on the footpath in some cases. You know, you don't really want to be driving along the footpath, do you? You certainly don't want to be walking out there. But these sorts of systems will be able to give you accurate readings of, you know, it could actually tell you, you could start creating systems where it says, you know, there's a bus coming, you know, don't walk out onto the road, or there's a bus coming, you might want to catch it. And 1 to 2 metres means a lot. So it's important for the nation's economy and various different things. This will also very much closely align us with the GPS network, or the ITRF, or International Terrestrial Reference Framework, which we all use in our devices today. So position is incredibly important. But in this project, we're going to be creating assets that will allow people to transform from different datums and parameters into this one. And it's stuff we've done before, and we're going to do it again. But into the future, in 2020 on, initially it's going to be just a fixed plate datum, but in 2020 and so forth, it's going to be a fixed plate time dependent. So it's going to shift with time. So as it shifts, we'll be able to give you calculations on your coordinates there. Again, all of this is going to be server-side type application. And as I've said, we have a lot of scientific data, and we talk to a lot of scientists and really intelligent people. But there's some other people that we talk to that's not their area of domain and may not understand. They may be a builder or a plumber or a doctor, and so they may not understand some of the things that we do. So a function that we've been using, courtesy of Esri, is a thing called story maps. And it allows us to tell the story of the activity that the Australian government is doing here. One of the story maps that's up there and out there at the moment is about the radioactive waste management facility. It's actually a really interesting thing. What it does, it brings together text and maps and motion to demonstrate and tell the story of the activity that you're doing to a common and a layman's person. So in that, there's a really interesting story here talking about how the phases of that radioactive waste selection will go. It'll tell you why we're doing it, which is really important. It links off to other little documents talking about why we have to store this stuff. Because, of course, it's a bit of a hot topic. But we need to understand that we have to do this. We have temporary locations out there we're storing radioactive waste. That's not so great. But in that, we're also creating things for the water observations from space, which I tell people about. And they should be interested in the capability that we're demonstrating here because, again, we're doing national coverages. I believe if we used to do things the old way, it would have taken 4.5 years to do the same thing that we can do in a day or 6 days with some increased algorithms. That's a huge increase. And think about what happens when we start having 20 times the amount of data coming in than we do now. Those brute force methods aren't going to work anymore. They're going to come to a grinding halt. You can only have so much supercomputing. But in these sorts of things, we can put together systems that can quickly get you results. It also means we can be reflexive and capable of reacting to situations. So here we're going to be talking about some WAFs. We want to also talk about the capabilities of the Sentinel system, which is going to become near real-time. Some people are proposing real-time, but that's possibly a little silly. The Law of the Sea guys are really interested in telling the story of the Seas and Submerged Lands Act, talking about the continental shelf, the contiguous zones, the water column. There's a whole bunch of concepts there of law in the sea that people need to understand, and there's a way to do that in this story maps. All right, this is the last slide. I'm going to talk a little bit about some of these things that some really smart people in this agency are setting us up for the win. Because, as I said, we're growing enormous amounts of data. It's getting larger and larger and larger. And the systems that we use today are really going to stop working one day. They're not going to work at all. So some of the concepts that we're working with, and there's some other workflow things there, things like linked data. Now we've got Nick Carr that does, every Tuesday he does a little presentation on linked data. And I'm going to talk about today the reasons why we need it. And I think I've alluded to some of them as well. So what is linked data? So it is just that. It's linking data and categories and science together. So things don't sit in silos and islands. They actually start to become related to each other. And one of the research areas in this area is something called web semantic, or the semantic web. And what it does, it enables us to link data together with semantics such as it belongs to, it's within, or is a customer of, or an employee of, or belongs in the area. And what that enables us to do is we as human beings can start creating those links and relationships together, and we can start walking or crosswalking through the areas of science. Now what does that mean for geospatial stuff? Well, we've done some research with CSIRO, and we did some semantic links and with administration boundaries and gazetteered places. So we said, near Mount Isa, there are these roads and there are these networks. But what does it mean? I mean, what's the goal? What's the point here? We can actually teach computer systems about the semantics there. So what it means is one day we'll have computer systems, this is a little bit Web 4.0 if you want to go there. We could ask your Siri or computer, you know, what's the mineral potential in the southern region of Mount Isa? And with these sort of linked data and semantics, including functions, the computer would be able to go away and use these models and algorithms to say, well, you know, in the south region, you've got these geological mineral potential formations, so there's a likelihood that there could be copper or not. But is it viable resource based on the current price? So you've got the current price. We know that there's this much estimated topsoil. We know that there's a road that's not going to work for trucks, so you're going to have to invest in that area. You're going to have to buy and build that road. When will that become economically viable and stuff like that? And you'll be actually, using linked data, be able to ask systems to intelligently map these things together. And it's futuristic stuff, but it's not really. I mean, if you think about planes are now sort of flying themselves. Think about the linked data and systems that need to be involved there to know the plane needs to go from A to B. Look at the weather patterns. Is it going to be rough? Is the landing strip and so forth? These sorts of systems is the only way that we can basically evolve the amounts of data that we're building. We have to intelligently link them together, and we can teach computers how to use them. So the other things that we're doing in the agency to help move things forward, we're going to be doing online forms. So you'll be able to, if you want to create a web service or something like that, you'll be able to go to a website, you'll be able to register your interest, put it forward. It will go through a stages of workflows and proposals. It will go to the right people to authorise the thing, and then all of a sudden we're doing all of this online and we're understanding the things that we're publishing and we're putting out there. So there's these systems are being built, or thinking about being built at least. Also robot metadata. Who likes making metadata? I don't think anyone does. Wouldn't it be nice, and haven't you ever thought that when you're doing metadata that this could be done easier, much, much easier? Well, there's been discussions, initial discussions, and talks about creating robots to automatically fill in sections of your metadata. But not just that, trawl through the historical repository and give us a rating or evaluation on how we've done in the past and what we can fix. Because as you can see, our data is only good as a metadata, because the metadata will reflect whether the machine should use it or not, or can use it. So if we don't have good metadata, none of these systems are going to work. So we really need to work on it. But instead of manually going through each of the one and looking, it wouldn't be great if we could have a robot which could come up with some decisions for us and say, you know, you need to increase your abstract, or you don't have any lineage, or your coordinates for the envelope are wrong. And we need to work on these systems. You've heard a lot about enhanced catalogue searching systems. So we're going to have internal and external capabilities for searching of catalogues. You'll be able to, at your desktop, very quickly be able to find out what we have and what we don't have, which would be quite useful. And something which is another little hot topic are vocabulary services. So keywords. We can have consistent and keywords with scientific principles. And when we go to create the metadata, or the robot does it for us, it could suggest some keywords related to our data. And we can basically then, again, consistently start having the same results when you go searching for things. But it's not just that. What is a particular mineral in one language may be something else in another language. So with vocabulary services, you can also start looking at systems which can look at evaluating in Japanese and French and Spanish and so forth. But you've got to bring these systems together to make it work. But there are some really smart people in the agency that are thinking about this now and working on these sorts of things now. But that is the end of the presentation, and I didn't do any little visual things, but a lot of the systems that I talked about at the start, a lot of them are online. Some of them aren't for various different reasons, but one day in the future they would be. So I encourage you to go and have a look. And don't just say, well, look, it's another portal, because there is a plan at the moment that we're trying to enact to start bringing these functions together in an intelligent way, that things will become easier for us. I mean, are we inherently lazy, or do we want to be more efficient as a human race? Well, it's actually a little bit of a mix of both. We need to start becoming more efficient, especially the public service, because there's less resources to do these things, and there are some things you don't need to do.